Qengeba Sojola here. In this video, we'll be basically looking at the second type of classification of fuel cells that you can find in the market. This group is particularly known as high temperature fuel cells. There are about two high temperature fuel cells that I have found in the market, right? And they are namely known as a solid oxide fuel cell, right? And a molten carbonate fuel cell. Now, when we look at the solid oxide fuel cells, right? Now, this fuel cell can use a number of resources, right, as a fuel or as an anode gas, right? The gas that you send to the anode. Now, the gases are, namely, you can use hydrogen itself, right? You can use natural gas, right? Which is mostly composed of methane gas, right? You can use coal gas, right? And you can use something known as biogas, right? Now, to promote and make sure that this reaction happens and produces results, something known as a zirconium oxide, right, electrolyte is used. This is a hard, non-porous ceramic compound, right, which is fundamentally used as an electrolyte in the solid um, oxide fuel cell, right? Now, the operating temperature of this type of fuel cell can range from 700 degrees Celsius to 1,000 degrees Celsius, right? Now, when we look at its efficiency in producing this energy, right, it ranges at about, I'd say, 50 to about 65%, right? And this type of fuel cell can be used for a number of things. Now, it can be used for portable purposes, right? It can be used for transportation, right? And it can be used for stationary fuel cells that you might need, let's say, in a power station. Now, because of the high temperature, right, that is released within this reaction, right, it means that we can add a steam turbine, right, that can also produce electricity. We can basically create a cogeneration a steam cycle, right, that can add electricity in the ultimate producing of the electricity by the fuel cell. So you can have a fuel cell and a steam turbine, right? Using the heat to turn the water into a steam so that you can send it to a turbine, right? So this is the first type of high temperature fuel cell that you can find, yes, in the market. Now, the second type of high temperature fuel cell that I have found on the market is basically known as a molten carbonate, right? A molten carbonate fuel cell. Now, it's known as a molten carbonate because of the essentially the type of electrolyte which is used. Mostly, the type of electrolytes which are used are basically carbonate salts, right? But in this case, the actual fuel cell that I've come across uses an electrolyte that is known as a lithium potassium carbonate, right? Now, when the fuel cells operate, right, its operating temperature stands at about 650 degrees Celsius, right? It tends to melt this lithium potassium carbonate, right, to form a liquid molten solution. When it is liquid molten, right, it can allow various things to happen. The transfer of ions, protons, and electrons within the fuel cell, right? When this happens, there is an electrical charge that is generated by the fuel cell. Now, this type of fuel cell is fundamentally used for stationary purposes, right? And it stands at an efficiency of about I'd say 50% to about 55%. Now, the reason the two high temperature fuel cells are able to use various types of fuel or various types of resources as fuel, right? As I've mentioned, they both can use hydrogen, pure hydrogen. They both can use natural gas, right? Which has a high methane content in it. They both can use coal gas, right? And they both can use biogas. Now, it is because in high temperature fuel cells, right, a process known as internal reforming occurs. Now, when we speak of reforming, we are fundamentally speaking of a way that is currently used to produce hydrogen. The way you do this is by mixing steam, right? Water in its steam form with natural gas, right? When you mix these two, right, the hydrogen particle or the hydrogen molecule is separated to be on its own, right? And then a carbon monoxide uh, uh, molecule known as sign gas, right? Synthetic gas is produced, right? So this process occurs naturally and automatically within the fuel cell because of the levels of temperatures that allows for this reaction to occur, right? Usually you would need to have an external reforming facility that does that first, right? And then uses the hydrogen in the fuel cell. But in this case, you don't need to reform your fuel, right, or produce hydrogen outside. So you can feed the fuel cell with, let's say, natural gas, and because of its own operating temperatures, which stand at about over 650 to about 1,000, right, using those processes and that heat, right, hydrogen is produced inside and is fed into the fuel cell to fundamentally produce electricity, right? So yeah, this is what we talk about when we talk about high temperature fuel cells in the market. Thank you for this opportunity. I'll see you in the next video.